Today we're going to talk about section 2.4, surveys and cardinal numbers. And the first thing I want to show you is a formula. So this is actually the first formula I believe that we've looked at in this class. And this formula is going to help us when we're working with our Venn diagrams. It looks like this. So it looks like this. It's the number of items in the union of two sets is equal to the number of items in one set plus the number of items in the second set. And the problem that would occur if this is all we looked at from a Venn diagram perspective, take a look here. You would have two sets that potentially at least overlap. The first set, you completely took everything inside of it. And then the second set, you take and add up everything inside of it too, and the problem is that you end up double counting the part in the overlap. So in this formula, what you need is a subtraction of the overlap, and the overlap is called the intersection in the last section. So we have that the number of items in the union is equal to the number of items in the first set plus the number of items in the second set and minus the intersection of items. Now we'll come back to this, not in the next slide, but the slide after that, and see how this is used. But I want to take a look at, show you something from a Venn diagram perspective that sometimes we don't even need the formula to be able to work with these. So if you take a look, we've got a Venn diagram. The difference between this Venn diagram and the Venn diagrams in the last section is in the last section we put numbers in the different areas as labels. These numbers here are cardinalities. That means they're representing the number of items within the set. How many items, for instance, are in set A, how many items are in the intersection, and so forth. So the first one we're going to look at is the intersection, and the intersection is the overlap of the circle. So the cardinality of this, the number of items in A intersect B, is equal to 6. And then the second one on part B is the number of items in the union. So the number of items in the union would be everything in either set or in the intersection. So that's going to include the 3 that's on the outside of A, the 6 that's in the overlap, and the 2 that's in the inside of B, or the outside area of B, which gives us a total of 11. Now, C, D, and E are a little different because they've all got prime notation, which means we want to remember that that means the number of items that are not in a certain set. So here we're looking at the number of items in A prime intersect B. So A prime would be everything not in A, which would include the 2 and the 7. And then we need to intersect that with set B. And of the 2 and the 7, the only item there that is also in set B would be the number 2. So this would be 2 items. All right, over here on part D, we've got the number of items in A intersect B prime. So set A has the numbers 3 and 6 in it, but B prime means we want it to not be in B, which would be the number 3. And then finally, we have the intersection of both of them. In other words, we want it to be not in A and not in B at all. And of course, the number that is not in A and it is also not in B is the number 7. All right, let's take a look at a different kind of a problem. This one right here talks about finding or making use of an appropriate formula. And there is only one formula that we have used, and it was on the first slide that we looked at today. And that was the number of items in the union is equal to the number of items in each set individually plus the number of items, minus, get the right thing, minus the number of items in the intersection. And it doesn't matter which of these 4 pieces of information I'm given. As long as I'm given 3 of them, I can solve for whichever one I'm not given. In this particular situation, they want me to find the union, which is the part that's on the left. So that's the part that I'm not given the information on. But I am told the number of items in set A is 8, The number of items in set B is 14. I need to subtract the number of items in the intersection, which they give me is 5. And if we add those together, we have 8 plus 14 and minus 5. So 14 minus 5 is 9, and 8 plus 9 is 17. So the number of items in A intersect B is 17. All right, on this next one, we've got a lot of information given. The first thing that we should notice is that there are 3 different sets that are referenced in the information. We've got set A, set B, and set C. So that's why our Venn diagram has those 3 circles in it. We're told information about A, B, and C individually. We're told information about sets when they combine 2 of them with an intersection, and they do that with each pair of them. And then the piece of information that is the most important for us at the moment is this one right here, where it tells us that the intersection of all 3 sets is 6. And that information gives us the very first location right here, and it gives us the value 6 in the very dead middle. And we're just going to work our way backwards through this. We'll come back to the n of u equals 50 at the very end, but aside from that, we're going to go backwards here. So taking a look at this second one back, I have the intersection of A and C. Well, the intersection of A and C includes the 6 that's in the very middle, but it also includes this little corner here that almost looks like a triangle on the left-hand side. So those 2 pieces have to add up to 15, which means I'm missing 9 of them. So working our way again backwards one more time, we've got the intersection of B and C, which is over here in the bottom right-hand corner. Well, again, it includes the 6, but it needs to be a total of 8, which means I'm missing 2 in this piece, so it adds up to the total of 8 in the intersection. Okay, the last intersection is A and B, which would be the top and the middle, and it includes, again, the 6, plus something else to make up 10, which means I'm missing 4 of them that go in the middle. Once I have those intersection pieces found, I can find the outer pieces of A, B, and C. And again, we'll start just going backwards with C, which is 26. So the entire circle C, which includes the 9, the 6, and the 2, all add up to 26. And I need to find the missing piece to make that happen. So right now I have 9 and 6, which is 15, plus 2 is 17. And I'm supposed to have 26, which means there are 9 missing from this portion. So we can move on to set B. Set B says there's 24 in set B. Well, I've already got a 4 and a 6, so that's 10, plus 2 more is 12, which means I would be missing 12 from set B. Last one, set A, also 24. Right now I've got the 6 and the 4 and the overlap here in the middle that are in set A, so that's 10, plus 9 more, that's 19, which means I'm missing 5 in the outside area of A. All right, and then our final piece of information is here at the end when it tells us that n of u equals 50. So on this one, in other words, all of those numbers in the entire picture, every number I've written here in pink, plus the outside, which I haven't yet written in, have to add up to 50. So we're going to add up all the pieces on the inside of the puzzle. So we're going to add 5 plus 4 plus 12 plus the 9 plus the 6 plus the 2 plus the 9. And we find that we have 47 so far total, which means we're missing 3 to make it a total of 50. Now that our diagram has a value in each one of the locations, we're complete with this diagram. Now what I'd like to do is I'd like to show you how you go from a word problem into a Venn diagram. So this is a really simple, straightforward one. We have a Venn diagram we're supposed to create for Joe. Joe writes and produces albums for musicians. Last year he worked on 10 projects. He wrote and produced 2 of them. He wrote a total of 5, and he produced a total of 7. So the first thing we're going to do is recognize that this is a 2-circle Venn diagram. And the 2 circles are represented by what he wrote and what he produced. Now, if you go back over here, it said that he wrote and produced 2 projects. Well, that word "and" tells you we're in the intersection and it's in the middle. And then the second piece of information said that he wrote 5 projects. So that number 2 plus the missing piece have to add up to 5, meaning I've got a 3 in the outside edge on the left. And the next one is the produced, and it says he produced 7 projects. Again, there's a 2 in the middle in the produced circle, so I need 5 more over here in produced. And then I was told as well that he only had 10 projects that he worked on. And if you take a 5 and the 2 and the 3, that's already 10, which means there is 0 out here. So he didn't do anything else with those in any way, shape, or form. Then we can answer the questions asked. It asks how many projects did he write but not produce? As you can see in our Venn diagram, that's 3. How many did he produce and not write? And again, in the Venn diagram, you can see that that is 5. And then how many did he neither write nor produce? And that was the 0 that we came up with there at the very end. So this is the way that you think about these Venn diagrams. And now we've had a chance to look at a very simple, straightforward one. We're going to do one that's a little more complicated. At the University of Louisiana, half of the 48 mathematics majors, are receiving federal financial aid as follows. 5 have Pell Grants, 14 are in work study, 4 have top scholarships, and 2 have top scholarships and are in work study. And then those with Pell Grants had no other financial aid. So if you look carefully again, there are 3 circles here, one for Pell Grants, one for work study, and one for this top scholarships. So I've got a 3-circled Venn diagram. I'm going to put in the Pell Grants on the top left, and then I'll put work study on the right, and I'll put tops down here on bottom. Now, we're going to put some numbers in here, but we can actually take one look at something else real quick just to make it real clear in our minds. It says half of the 48 mathematics majors. So how many is half? That's what you get, 24. So 24 is going to be inside of my diagram, a total of 24. Now, if you combine the first statement, 5 had Pell Grants, with the last statement, those who have Pell Grants have no other financial aid, you can actually put the 5 in the outside area of the Pell circle. Because it said that if you have a Pell Grant, you don't have any work studies. There's a 0 here and a 0 here. And if you have a Pell Grant, you don't have any soft scholarships, so that's a 0 here as well. So we get a lot of it filled in just by those 2 pieces of information. All right, so looking back again, it says, well, we've got 14 in work study, but I've got several areas of my work study picture. I don't want to put that one in yet. 4 with top scholarships. Again, I've got several areas that 4 could go in. However, the one that says that there are 2 with top scholarships and in work study gives us good information. It tells us that there's a 2 right here because it's supposed to be in the work study and in tops. Now it says 4 have top scholarships, so there's 2 in top scholarships, which means there's 2 more out here. There we go. And in the work study, it tells us over here that on the work study that there are 14 in work study, and I only have 2 listed, which means I'm missing 12 of them. Now if we add this up, 12 plus 2 plus 2 is 16, plus 5 more is 21. 16 and 21 leaves me with 4 who are getting some kind of financial aid, but it is not one of these forms. So this is students with federal aid. That is what this rectangle is representing here. Now, the first question it asks us is not directly on this diagram, but it relates to it. It asks us, how many of the 48 majors had no federal aid? Now, notice it doesn't say had no aid, right? It says had no federal aid. It doesn't say have no aid that's not a Pell Grant work study or top scholarship. It says have no federal aid. And if you go back to the problem and read it in carefully, it says half of the 48 are receiving federal financial aid. So the other half must not be. So this would be 24. Now the one that says more than one of these forms of aid, well, that's going to be in any part of those overlapping pieces, and that would give us 2. Federal aid other than these three forms, and that would be the 4 that's on the outside. And then top scholarships or work study means that I add up all of the values within the top circle and the work study circle. So I have 2, 2, and 12, which means I have a total of 16 who have top scholarships or work study.